Hello, my name is Priyesh. I'm a researcher in artificial intelligence and systems for artificial intelligence, specifically targeting the AI models towards edge platform, that is deploying them in smartphones and drones. In this video, we are going to discuss a very important technique in machine learning called as regularization, and specifically using a dropout technique for regularization. So first and foremost, what is the need for regularization in neural network or machine learning? So to prepare any machine learning model, we need that the model should predict with very good accuracy over a very wide range or variety of data. We don't want our model to perform really very well for just a very narrow class of data, but then it fails to do so for other wide range of data or other data or unknown data that is beyond the range for which the model has been trained for. Such a problem is called as overfitting. So we want to alleviate the problem of overfitting. And therefore there is a need for our model to be more generic or generalizable or regularization. So in order to impose regularization, once this technique is dropout, which is very commonly used, and what dropout does is that it randomly drops off certain neuron units from the network layers with a certain probability, which is called as dropout probability. The effect of that is that certain neurons that might have been heavily biased towards a particular prediction, their effect has now been alleviated. That is, the overfitting problem has now been alleviated by imposing the dropout layers during the training. So that is the benefit of dropout. And the same is illustrated in this particular demo, where you can see that the neuron units are dropped off randomly and the skip connections are therefore dropped off. And thus there is no impact of that towards the inference or prediction accuracy. So in PyTorch, there's a particular class called as torch.nn.dropout that has a dropout layer, which we can define in this particular way. The argument of which is the dropout probability. It could be any number, 25% or 50%. That is, the 25% of neurons in this particular case are dropped off from a particular layer. And we define the dropout layer along with other layers in the network class that is as defined over here. And the same is applied with the layer on which we want to impose dropout in the forward definition function. That is, we are imposing dropout on the last layer of the network. So that's how we implement dropout during the training. Thank you.